Hello friends, so today we're going to discuss the top 3 problems from the latest LEETCODE bi-weekly contest 34. So let's start. The first problem name is matrix diagonal sum, in which you are given a square matrix and you have to return the sum of its matrix diagonals. As you can see, this is the primary diagonal, this is the secondary diagonal, so you just have to add all these numbers and return out. So to iterate over these numbers, you just have to find out the pattern to iterate over the diagonals. The index of this is 0, 0. This is 1, 1. This is 2, 2. So you just have to iterate over from this side. You just have to do. I'll take down to the code part. So what you can do, you can iterate over from I equal to 0 till I equal to n, because it is a square matrix, and you just iterate over the matrix for I, I. Okay. And now if you want to iterate over the secondary diagonal, then this is 0, n. This is 1, n minus 1. This is like 2, n minus 2. So this is I and this is n minus I. So the second value is I and n minus I minus 1, because it's the last value. N doesn't exist, so it's n minus 1, the last index. But the main one more thing in this is, as you can see, if the matrix is odd, the length of this matrix is odd, then the middle element is double counted. But if it is even, as you can see, then it is not double counted. So that middle element is not there. So what you can do, you have to just check also that if the length of this matrix is odd, then you will subtract the middle element from this, because you have double counted. Else you don't subtract it, you just print out the total. So that's the logic for the first question. It's very simple. Let's move on to the second question now. The second question said that you are given a binary string S and you have to split that binary string into 3 non-empty strings, okay, such that you concatenate all those strings to form or to get the original string. So you have to split the original string into 3 halves, such that all the 3 halves has same number of ones. The number of ones in every half should be same. So you have to find out in how many ways you can split this string S into 3 halves, in how many ways, such that you will get equal number of ones in every half. That's the question. Now, because the number of ways to do such operation is very large, so you have to return it with modulo of 10 to the power 9 plus 7. So that's the question. Now, to understand this question, let's draw out some test cases to even make it more clear. Okay, let's assume that you are given some string in which there are 4 ones. Now there is no way to draw 2 stretches or 2 cuts such that every part has equal number of ones, because you cannot divide ones in every half equally. So the first condition is the total number of ones should be n, which is total number of ones in there, should be modulus 3, should be divisible by 3. Okay, then only you can divide them equally into 3 halves. That's the first logic or first thing you have to understand. Then the second thing what you can understand from here only, okay, let's assume that this can be easily divisible by 3. So first draw this example, which is 1 0 1 0 1. So now it has 3 number of ones, and if you find out that 3 divisible by 3 is equal to 0, so which means that I can divide it in somehow that total number of 1 in every half is equal to same. Okay, now because if every half have same number of 3's, we can easily find it out. How we can find out? If we divide 3, the total number of ones in this divided by 3, we will get equal to 1. What does this mean? It means that every half should be equal or would be having only 1 number of ones. Okay, so now what you can do here is iterate from left to right and ignore the half till that there is 1 number of ones. What does this mean? Let's assume that you have 1 2 3 4 5 6. This is a string of length in which there are 6 ones. Okay, 6 divided by 3 is equal to 2, which means that first it is divisible by 3. So we can somehow do some operations such that we can divide this into 3 halves which all have equal number of ones. Now how many ones we have to, in every half, how many ones will be there? 2. This is not that I have to somehow divide this in 3 halves such that every half should have 2 ones. Okay, can I divide this at this position? No. Can I divide this after this one? Yes, because after this one there are 2 ones. So I can take a call or take a half like this. I can make a half like this. Okay, I can make a half like this. but I cannot take now this. So I only have this much of positions to take. So if I can count out after after counting out 2 ones, how many zeros are there, because I cannot go or take one more 1. I can only put a slash in those zeros region. Okay, so if I count out that, okay, there are 2 zeros here. Now again move on and count 2 more ones. I counted 2 more ones. Now I can only cut it at this position. So how many zeros are also between this one and this one, which is equal to 0, like there is no 0. So what you can understand here is there is only up now how many positions are there to put a slash here. There's only one position. And how many positions are there? There's only 1, 2 and 3 positions. So actually the number of zeros plus 1 is the number of cuts you can do. So the number of cuts I can put in this position is this, and number of cuts I can put in this position is this. And now you just can put the total number of cuts can be multiplied by both of them. Why? Because I can put 1 cut here and 1 cut here, 1 cut here and 1 cut here. So it's like for every cut on this position I can put a 1 cut here. So it's like this, multiply with this. So it is like 3 into 1, which is equal to 1. So what you actually have to find out, you have to find out how many, like what is the subsection you have to leave, then how many zeros are there, then again leave the same subsection which has equal number of ones equal to this, and then how many zeros are again there. Now add 1 to them, and then that's the answer. But this is the case when there is at least one, like some ones here. But if there is no one, there is one example here also, like there is no one, there is everything is 0. Now if everything is 0, the case can be, as you can see in this example also, if everything is 1, I can put I can draw it out also. Okay, so how many positions are there in which I can put some cuts? I can put cut here, here, here. So if there are 4 zeros, I have 3 positions to put some cut, and in those 3 positions I have to put 2 cuts. So 3 C2. In those 3 positions I can put 2 cuts. So how many number of ways can be there? 3 into 2 divided by 2, which is equal to 3. So what does this mean? It means that, okay, for these 3 positions I can put that cuts. So that's the 2 test cases you have to see that. So what you can do, this is the function I actually always write when I have to do some operations using mod. So I have also made a video on it, you can go and watch it out. It's just finding out the mod operations easily. So that's the function in which first iterate over the whole array and see how many ones are there. Okay, if the total number of ones is not divisible by 3, then answer is 0, because you cannot even cut them out. Then if the total is equal to 0, like there is no 1, then I have to take care of this condition in which there are like no ones, all of them are zeros. So answer is just like 3C2. 3C2 means how many zeros are there. So if everything is 0, the total length is n, so n minus 1 divide C2. So that's the logic for the for everything is 0. So first n minus 1, and then you just have to multiply n into n minus 1, because I have subtracted n. So n into n minus 1, that's the thing. It is n into n minus 1 divided by 2, and divide by 2. That's the answer if everything is 0. Else this is not also the case, then what we'll do, we will find out the cut value. What is the cut value? Which is 3. Then what we'll do, we will make a vector and iterate over this sequence which we are given. And then what we'll do, we will check that, okay, if we find out a 1, we'll increase our total. Whenever our total is equal to cut, which means that, okay, now we are iterating from left to right and we have seen cut number of ones, so it means that, okay, now we have to do 1 cut. So if we have to do 1 cut at this position, we have to find out how many zeros are there between this position and the next one. So I will iterate over for I over the next one. If there is a 0, we will iterate over, keep on iterating till we find out the next one. If I find out the next one, what we'll do, we have found out how many zeros are there, so we will push back the number of zeros between the current cut and the next one in this like vector. Okay, and after pushing that, what we will do, the answer is just this vector will store 2 values, because I have 2 cuts position. Now there are some zeros, then there is some section again, and there are some zeros. So there will be always to be some amount of zeros here. So what answer is, take this number of zeros plus 1, take number of these zeros plus 1, and multiply both of these values. So that's what I've done. take the first value in this vector and the second value in this vector, add 1 to them and multiply them, and this is the answer. So that's the logic for the second question. I hope you understand that. Let's move on to the third question now. Third question is also pretty good, in which you have to find out the shortest subarray which you have to remove, such that the array which is left after removing that subarray becomes sorted. So what you are actually given here is, in this question you are given some array and then you have to remove out some subarray such that the remaining element in ARR are non-decreasing. Okay, so now you have to remove out the smallest possible continuous subsection. So as you can see in this subsection, if you remove out 10, 4 and 3, this part, then the remaining part is 1, 2, 3, 3, 5, which is non-decreasing. Okay, so now you have to find out this smallest number of subarray you have to remove. Now the main trick in this question to observe here is, you only can remove one subarray. Now let's assume that you have some subarray. Okay, now your only choice can be, this is some subarray, you can only remove some subsection in this subarray, and then there is some prefix and some suffix. Then if you remove out some subsection, there is some prefix left and some suffix left, which will form a perfect or a non-decreasing sequence. So now what you can easily do here is, for every prefix I can find out a particular suffix which is particular. Like for every prefix value, if it is non-decreasing, we will take this prefix, and then for this prefix I will find out some suffix which is also greater than this value, such that there can be a case in which it is 1, 2, 3. Okay, and then there is also case 1, 2, 3. Though both of them are non-decreasing, both of them are decreasing, but I cannot stitch this and this. I cannot put 1, 2, 3, 1, 2, 3. Okay, cannot stitch everything out. So I have to match also, such that the largest value of this prefix should be smaller than the smallest value of this suffix, and that's how we can do. So this is the main crux of this problem. So now how we can sort this out? So what I actually done here is, I first iterated over the array from left to right and stored a vector of array what is the maximum increasing or non-decreasing subarray prefix from left to right. Actually store them in a vector. So what actually I've done here is, I will explain you with this example. So let's copy out this example to make it more clear. Let's remove this out. So that's the subarray. Now what you can do, I have made a vector which is left. Okay, and then what will I do? I will iterate over from left to right and store the elements which are not decreasing in this vector. So because as you can see, just move from left to right. If the vector is increasing, then store this in left. So 1 is increasing, then 2 is increasing, okay, 3 is increasing, 10 is increasing, but 4 is decreasing. So left out. Now break out of this loop. So this is the the largest increasing subarray from the left. Now do it same for the right. Okay, but now for the right, store it like this. Okay, 5, then 3, then 2. Okay, for this 2, this is the maximum increasing subsequence. This is the suffix. Okay, and what you can now actually do here is, for every prefix, okay, because this is sorted, so what you can do? You can do a binary search. So for 1, you can do a binary search on this and find out, okay, if I want to attach only this prefix with a suffix, what is the length I have to attach? I have to attach it to 2, because 2 is the smallest element which is greater than this element. So I can attach both of them, and thus the length of the attached, if I attach 1 and this part, then the subarray which I have to delete is this, which is of length 4. This is the first thing. Now okay, take this subarray of length 1 and 2. Now if I have to take this, then I have to find out some more elements in the right which is greater than or equal to right. So okay, I find out, okay, now this is again, because 2 is also equal to 2, so I can stitch this part again. So if I stitch this and this, then the thing I have to remove is this, which is equal to 3. So this is smaller. Now I'll take 3. I'll take a subarray of length 3. If I take a subarray of length 3, then I can stitch it with this subarray. How we can find out? We can use binary search. to find out the element which is greater than or equal to this element. We just use lower bound. Okay, so I will find out, okay, 3. So now I can stitch this 1, 2, 3 and this element 1 and 3. So total subarray which will form after stitching is 3 plus 2, which is 5, and total length is 3. So I can either say like the minimum length, or we have to delete is length 3. And we just iterate over for all the left. We have find out for the right values how we can stitch them, and then we can find out. But the one more like base case you have to see here is that the whole array is actually increasing. If the whole array is increasing only, you don't have to decrease or like do anything. So you just also have to check that if everything is increasing only, you don't have to do anything. You just return out 0, that there is the answer. You don't have to return out or don't have to delete some subarray. It's actually always sorted. So that's the logic for the third question. Let's move on to the code part. So this is the code in which first take the input of n, the length of this subarray. This is the left. So in left, what you can do here is, because one element is always sorted, like the one element, if you take only one element, it's always sorted. So what you can do, first always push the first element, leftmost element, and then iterate over from the second element and check that, okay, whether this is greater than or equal to the last element which we have pushed in the left. If it's greater than or equal to this, like I can even push more because it is greater, so I will push. Else if I can't push, I will break out. Same I can do for right, push the last element and then start from the second last element and then keep on pushing. If it's smaller than, because it is larger, I have to choose the next element which is smaller than or equal to this element. So I will push back like this, 5, 3, 2, and then 4 is greater, so I will break out. But this is actually the reverse of the array. I actually want like this. This is not the suffix, or sorry, this is not the suffix, yes. So the suffix is 2, 3, 5. But if I push them in a vector, it will be formed like this. So I have to actually also reverse this. So after forming out this right vector, I will actually also have to reverse this out. But there are two cases also. If n is equal to 1, which means that the length of this whole array is only 1, then we don't have to do anything. The answer is just 0. Or also, which we have told you, if the increasing length, if the right is equal to n, what does this mean? If the whole array is increasing, then what you can observe here is the left array actually stores out all the elements. So the length of this will become equal to n. So if left of n is equal to n or right equal to n, then like if it is increasing only, you don't have to do anything. So that you just return out 0. Else what you can do, because right will store out the elements in reverse order, you have to reverse it again. And then what you can do, okay, then you have to find out the minimum value. The minimum value can be initialized with, so I have find out two vectors. The vectors which is this increasing from the left and increasing from the right. Okay, if I take only this vector, nothing else, then how much I have to remove? I have to remove total length minus this length of the left vector. That's what I've done. Initialize with this, whichever is the minimum of n minus the left size vector and the right size vector, whichever is the minimum. And then what will I do? I will iterate over for every left value. I will find the lower bound in the right value, and then I will check that, okay, if I have for every left value I have taken this right value, the total stitched length is this plus this, and now I have to remove this is stitched length minus the total length. So what I have to remove is stitch, like this is a stitch length, right side plus like the other value. And then what actually have to find out, the total length what we have to remove, or the subarray which we have to remove is n total length minus the left array size, because it is I plus 1, and the right is this. Right means what is the right subarray size, and this is the left subarray size, and remove minus this whole subarray size from the total will tell us how many subarrays, like the total size of subarray we have to remove, and we have to minimize it over all the values, and then we return out the minimum value. I hope you understand the logic as the code of this problem. Still any doubts, please mention down. Thank you for watching this video. I'll see you next one. Keep coding. Bye.